Hi, good morning. Today's session I'm going to explain the new concept scalar and vector fields. The first session I'm going to already explain scalar and vector. Scalar nothing but what it has only one magnitude. Vector nothing but both magnitude and direction. Here scalar field. A scalar field is something that has a particular value at every point in space. Vector field is same as the scalar field, but except for only having a value at every point in space, it has a value and direction at every point in space. It is a value and direction. It has only one point in a space. Okay, these are a scalar field and vector field. Example for scalar and vector fields are, these are all example. The first video already explained the same examples, scalar and vector. Here is a scalar field and vector field is same thing, same examples. Scalar field usually represented by pi symbol. Pi is equal to xy plus y square plus z square. Pi is equal to 2xy plus xy square plus z. Or pi is equal to xy plus y square plus z square plus 1. These are all example for scalar field. Scalar field generally represented by pi symbol. Okay, surface or scalar field, same, both are same. Next, vector fields are vectors usually represented by capital letters. Capital letters, vector A, R vector F, R vector P. Usually vector represented by capital letters. Therefore, vector nothing but it has both the direction and magnitude. Scalar nothing but it has only direction. It has only magnitude, no direction. Okay, IJK term. Here the important concept is, here we can convert scalar to vector using some differential operator, vector differential operator. This is very important concept. Here del nothing but vector differential operator. Using this vector differential operator, we can convert scalar to a vector. So therefore the del is defined as dou by dou x into I plus dou by dou y into j plus dou by dou z into k, nothing but vector differential operator. Using this vector differential operator, we can convert scalar to vector form. The procedure is very simple. For example, I consider pi is equal to, simple problem I take, xy plus y square plus 1. Okay, this is a pi function. So it is a what? Magnitude 1, only magnitude, scalar function. I am going to convert to vector form using this vector differential operator. Therefore, I multiply this pi function with vector differential operator del. What happened is del nothing but dou by dou x into I plus dou by dou y into j plus dou by dou z into k. So del multiply with the pi xy plus y as y square plus 1 means pi multiply with the del notation vector differential operator, we get vector form, scalar conversion to vector. The next procedure is, just take xy plus y square plus 1 inside multiplication. So we get dou by dou x into, the function is what, xy plus y square plus 1 into I plus dou by dou y into xy plus y square plus 1 of j plus the third term is dou by dou z of xy plus y square plus z square of k. Okay. Next, dou by dou x nothing but what, partially differentiate this function with respect to x. With respect to x means other variables are y and z are constant. So x square with respect to x differentiation is 2x, y square 0 and 1 is 0. With respect to x, y 0 and 1 constant is 0, we get 2x into y plus second term differentiate with respect to y. The first term is 0, y square become 2y into j. The third term differentiate with respect to z, no z term here, x square y square plus 1 constant term, we get 0 into k. Therefore del pi nothing but 2xi plus 2yj plus 0k, nothing but 0, we get vector. Okay, the previous is what, scalar function. We can convert to vector form using this del operator, means vector differential operator. This is very important. Using this vector differential operator, we can convert scalar to vector. This is the procedure. Okay, so instead of this function multiply with each term, direct method means directly you can differentiate these with respect to x, with respect to y, with respect to z, we get the final solution. Directly we can, instead of multiply with each term, directly we can differentiate the pi function with respect to x, with respect to y, with respect to z, we get direct vector function. Okay, this is a vector differential operator. Operator del or vector differential operator, del nothing but dou by dou x into I plus dou by dou into j plus dou by dou z into k. Okay, next video I'll explain the problems. Okay.